Hello, let us look at some questions from June 2015 uh, geometry regions. So here comes the first one. We have this triangle is being rotated about leg RS, which means this leg right over here. Then what kind of shape can we imagine? Now, of course, what would have happened is as this one turns around this way, you see that triangle coming out on the other side, and it will be some sort of circular. That means essentially we are looking at a cone. So therefore, choice 4 would have been our answer. Let's look at the second question here. The vertices of triangle JKL are these, right? Under which transformation is image not congruent, meaning not the same size. Usually that happens with dilation, with the factor that is not equal to 1 or negative 1. And we see the answer right over here. Dilation with a scale factor of 2. Then each side will be doubled. All right, number 3, the center of the circle Q has coordinates this one. All right, if the circle Q passes through this particular point, let us try to sketch that and see what we end up getting. Here we have center is 3, negative 2. Let us say this is our center. And then passes through 7, 1. That means we are getting a circle, something like this way. And you can easily see that your radius would have been that length. We can find the length of the radius and then find the diameter. Let us try to find the radius first. Either you can use the distance formula, or you can see that vertical difference from 1 through negative 2 is equal to 3. Horizontal difference between 3 and 7 is equal to 4. So we are looking at 3, 4, and then this one must be then 5. Or you can use the Pythagorean theorem as well. So 3 squared plus 4 squared equals 5 squared. So then we know that the 5 is the radius, hence diameter is 10. Choice 3 becomes the answer. How about number 4? Congruent figures 1, 2, and then 3 are drawn here. Which sequence of the transformation maps the figure 1 to 2 and then 3? So 1 to 2, what happened? Notice that all these letterings are exactly on the same location, meaning it probably translated from 1 to 2. Now, so I'm looking at translation. Then can it be after that reflection or rotation? Now, there's a particular way for us to look at to see if something is a reflection or rotation. In order for something to be the reflection, I have to have a line where 2 and 3 will be the mirror image of each other. But due to the orientation, due to the how things are tilted, it doesn't seem to be. But on the other hand, rotation seems to be the answer, especially at the origin. Let me try to draw a couple line segments here for you. So the E rotated from here to here. Let us see if that will be the same rotation for another angle as well. How about D? D went from here to here. And then I'm going to try to move this one back and then see if it matches. This is the same angle. Then it must be E and D at least has been moved to the same location, rotated by same amount. And that would be in fact true for all of them. So therefore our answer is in fact choice 4. All right, let's look at number 5 here together. So we realize that this is 34 degrees. The point is 20 feet from the base of the tree. So this is 20. What is the height of the tree? So I don't know what it is. I'm going to call that as x. Then what kind of relationship do we see between x and 20? That's right, it's tangent relationship. So we could have tangent of 34 degrees is equal to x over 20. Then I can simply cross multiply them to get x equals 20 tangent of 34 degrees. Oops. 34 degrees. Now, all you have to do is put them into your calculator. So, making sure that my mode is in the degrees. I can see that here. All right, now, then I could have tangent 20 times tangent of 34. Then you can see that it's about 13.5. So our answer will be choice 3 becomes the answer. All right, let's move on to the next question. Number 6. Which figure can have the same cross section as the sphere? You see, one thing about the sphere is that no matter where you cut it, you'll always end up getting the circles. So which one of them has a circular cross section? In fact, the answer is cone, because if you cut it horizontally, you will always get circles. All right, so that was number 6. Let's look at number 7. Shipping container is in the shape of right rectangular prism, dimension of 12, 8.5, and then 4 feet. Container is completely filled with content that weighs on average of this much per cubic foot. Cubic foot represents the volume, unit of the volume. And then you can find the volume earlier here. Then what is the weight in pounds? So in this case, to find the weight, all we have to do is density, which is this one that's given, multiply that by the volume. Then density is 0.25 and volume is 12 times 4 times 8.5. So I'm just going to multiply them out here. 0.25 times 12 times 4 times 8.5. Then it looks like 1 or 2 seems to be our answer. Choice 3. All right. Let's look at number 8. In the diagram, circle A, chord CD, and then those are all drawn here. Which statement is not always true? Is CG congruent to FG? CG is this green highlighted one, and FG is the blue highlighted one. Do they have to be equal to each other? No. So the answer seems to be first one anyway already. But let's talk about the second one. Angle CEG. Why is this angle congruent to FDG? Why are these two angles congruent to each other? Because they share the same arc, you see. So therefore, this red angle is the half of this arc. This purple angle is same as well. So therefore, they must be equal to each other. And how about CE over EG? And then if I were to cross multiply them, you will see that CE, actually CE is this one, this side, to EG, which means this one. These two purple sides is in fact the corresponding sides to FD and then DG. FD and then DG. You see these two sides are in the same corresponding place to these two when these two triangles are similar. So therefore, their ratios must be the same. That's why choice 3 is okay. And then as I was talking about choice 3, I mentioned that choice 4, they're similar. How are they similar? You need to have two pairs of the angles. One which we talked about it already. Second one is right over here. Vertical angles as well. So those two triangles are similar. All right, let's move on to the next question, number 9. Which equation represents a line that is perpendicular then I need to find the slope and then take the reciprocal of that. So then here, I'm gonna add y, so we get 2x and then subtract 7 is equal to y. That's what I'm getting. So we know that slope is equal to 2. That means the slope of the line that's perpendicular must be the negative of that, which is negative. Reciprocal of 2, which means negative 1/2. So slope has to be negative 1/2. In fact, only thing that has negative reciprocal slope would have been choice 1. All right, let's move on to next question, number 10. Which regular polygon has a minimum rotation of 45 degrees? That means if whatever the polygon would have been, this is a part of the polygon where I'm going to have some sort of number of sides on the other side. That angle is 45 degrees from here to here. That means if this one is moved over here, by rotating another 45 degrees, I should be able to get the same figure as well. In other words, the exterior angle has to be 45, so we get 360 divided by 45 should give me the number of sides. That's equal to 8. That's right. So we get octagon would have been our answer, choice 1. Number 11. So we realize that these two line segments are parallel, and AC is 9, AE is 9, and then ED is 5, and then AB is 9.2. All right, so we are looking at what is the length of AC. Don't forget AC is the whole thing. So then let me call the AC as a whole thing as X. Then here whole thing would have been 14 by adding 9 and 5. So our ratio would have been 9 over 14. Because upper one times the whole upper one of the whole thing, that should be the same ratio for 9.2 over whole thing, which is equal to X. Now we can see that 9X must be equal to 14 times 9.2, and I can divide each side by 9 to figure out the value of X. So we get 14 times 9.2, but divided by 9. So X equals 14.4. Choice 3 becomes the answer. All right, number 12. In scaling triangle, so we realize that angle C is right angle, which equation is always true. Notice that when this one is 90-degree angle, then angle A and angle B are complementary. As soon as they're complementary angles, then we realize that the sine of an angle must be equal to in this case, means the complementary, cosine of the angle B. How do you know that? When the angles are complementary, the cofunctions will be equal to each other. So I'm looking at something like that, which will be choice 4. All right, let's move on to the next question, number 13. Quadrilateral ABCD has a diagonal. Now, which is not sufficient to prove that it's a parallelogram. It's kind of difficult, so I'm just going to draw a figure and AB, CD. So AC and then BD bisect each other. Will that be enough that something is a parallelogram? Yes, it is. That's one of the ways for you to prove that something is a parallelogram. AB is congruent to CD. One opposite pair are congruent, and then BC is congruent to AD. Yeah, when two pairs of opposite sides are congruent, it must be a parallelogram as well. How about the third one here? AB is congruent to CD. We got the first one done. And AB is parallel to CD. And that's correct as well, because when one pair of opposite sides are parallel and congruent, then it must be a parallelogram as well. How about 4? These two pairs are congruent, but the other two pairs are parallel. When those are not about the same line segment, just like how number 3 was used, otherwise it doesn't prove us anything. Choice 4 would have been the answer, therefore. Number 14. Now, the equation of the circle. Now, what we have to do is we simply have to complete the square. So here we get x squared, but I don't have any other x terms, so this is completely squared as well. plus y squared plus 6y, I'm going to leave blank, and then equals 7. What do I need on the last slot? I'm going to use this number divided by 2 and then square that. So divide by 2 gets me negative 3 or positive 3, and square that becomes plus 9. Then here we get x squared plus y plus 3 squared is equal to 16. Then the center of the x value is equal to 0. Y is in fact negative 3, so we're looking at choice 2 or 4. Radius is the square root of that. Choice 4 becomes the answer. All right, let us look at number 15. AB is 9 here, and then BC is equal to 15, and then DE is equal to 6, and then EF is equal to 10. And then angle B and angle E are congruent. So it looks like a SAS, similar, but in order for us to use SAS similarities, the ratio of the corresponding sides has to be the same. So it's 9 over 6. Is that in fact equal to 15 over 10? 9 over 6, I can divide each side by 3, so we get 3 over 2. Here I can divide each side by 5, then I get 3 over 2 as well. So it checks out as well. Now, then two triangles are similar, which is choice 3 would have been the answer. All right, let's move on to the next question, number 16. Triangle ABC is dilated by the scale factor of 3. Which statement is true? The length will be tripled, so that's correct. So as, but length will be tripled, but which side is tripled? In fact, this is 3 times of the original one, so A prime B prime in fact is equal to 3 times of AB. So in fact, the first one is not correct, hence the first one is the correct answer. Oh, actually, my bad, they're looking for what is true. The first one is not true because it has to be the other way around. That makes number 2 as true. How about number 3? Angles doesn't change in dilation one way or the other. So the second one would have been our answer. Number 17. Which statement will allow Steve to prove that 2 lines are parallel? When 2 lines are parallel, we're talking about alternating interior angles or corresponding angles. So here, CFG, this angle, is congruent to FCB. Are they alternate interior angles? They are, hence those 2 lines must be parallel. It seems like the one is the very good candidate. ABF is this angle, and then BFC. Are they alternate interior angle? They are alternate side, but it's not the interior angles that we are talking about here because this angle stopped at this point instead of going all the way down. So therefore, second one is out. Third one, EFB, which is this angle, and then CFB, which is this angle. So once again, these 2 are not supplementary angles, so therefore, third one is not it. So as if when you check it, fourth one will not be it either. So hence, number 1 is our answer. Number 18. So notice that CD is the image of AB, so AB is the original. And our image became smaller, so therefore our ratio has to reflect it as well, meaning the ratio has to be less than 1. So EC, which is this side, which is great, and then over EA. That's essentially how we can talk about the scaling factor of the dilation. But notice that EC is a smaller and EA is a bigger one, as the image becomes smaller. So the first one is correct. All right, let's move on to the next one. Number 19. A gallon of paint will cover approximately 450 square feet. And then measures 12 feet on each edge. What is the least amount of gallons of paint must she buy? So now, outside of surface of a cube. Cube, that means we have 6 faces, and then of each side becoming 12, each face becomes 12 square. So then that will give us the amount of surface area. So we get 6 times 12 square. And then I'll be dividing this one by 450. Then I get 1.92. That means number 2 would have been the answer. We need a little bit less than 2 cans, so we need at least 2 cans to paint the entire thing. Number 20. AC is perpendicular to CD, so they mentioned it over here. And then which statement is not always true? ACB, which is this angle, is that congruent to BCD? Are these two angles congruent? No, not necessarily. So therefore, first one is the answer because they're not always equal to each other. How about ABC? ABC is the right angle because it intercepts the half of the circle. And then ACD was a right angle as we mentioned earlier. BAC, which is this angle. And then DCB, which is this angle. Yeah, why are they equal to each other? Because this is an inscribed angle that covers arc BC. So is this one, which covers arc BC. When tangent and chord meet up together, that's basically what we end up getting. So it is true. Once again, only thing that's not true is choice 1. And then you can check up on the rest of them as well. All right, so here we get, notice A corresponds to D. And then B corresponds to E. And C corresponds to itself. AC is equal to 12. And corresponding side will be DC, but we'll see about that. DC is equal to 7. And DE is equal to 5. And then perimeter of the big triangle ABC is 30. So the whole thing is 30. What is the perimeter of the DEC, which is smaller triangle? Notice that perimeter shares the same ratio as the length because after all, perimeter is length as well. And then we get to realize that perimeter here is equal to 30. Perimeter here is our question mark x. So we get 12 to 7. That's the ratio of the corresponding size, as you can see. Now, that should be continued on 30 divided by x. Then we get 12x is equal to 210. X must be dividing. Let's try to look at it. 210 divided by 12. 17.5. So choice 4 becomes the answer. All right, let's move on to the next question, number 22. When a line is formed by dilation, we have to realize that slope will stay the same. Now, what does that mean? So then let me try to find the slope here. Slope here is divided by 3, so y is equal to negative 2x over 3. So negative 2/3 has to have the same slope. Now, then, which one has negative 2/3 as the slope? Let's look at the first one. I'm going to subtract 2x. So first one is 3y is equal to negative 2x plus 5 divided by 3. Y equals negative 2 over 3x plus something. Notice that they have the same slope. And no other has the same slope as that one. So choice 1 would have been the answer. And you can check up on the slopes for choice 2, 3, 4. And you will realize that no other will have the slope of negative 2 over 3. All right, number 23. Notice that radius of 5 and then divided into 24 pieces. Now then, if I have to use the highlighter here to show you, you see this yellow one everything put together is your circumference, which now has been split into two pieces. Then one piece here and one piece over here. Then the x, in fact, becomes one of those pieces, so we get to realize that's a half of the circumference, which is 2 pi r divided by 2, which is pi r. Pi, we know r is equal to, they said 5. Then we get 5 pi is what we're looking for. So what is 5 pi? 15.7. About 16 becomes the answer. All right, let's look at number 24. Now, number 24, here we have, which statement is sufficient evidence that this triangle is congruent to this triangle? Then we have to realize that all 5 congruence theorem has to be satisfied, any one of them, right? AB is congruent to DE, and then BC is congruent to EF. Those are 2 conditions, but all of them has 3 conditions. So first one is not it. Sorry. All right, next. How about angle D? Oh, 3 pairs of the angle can only show that 2 triangles are similar. In fact, you just need two of them, but that's not going to cut it. How about the third one? There is a sequence of rigid motions that maps AB onto DE. So AB will be onto DE, and then BC onto EF, and then AC onto DF. Oh, because rigid motion preserves the distances and angles, so therefore third one should have been our answer. 3 sides basically maps onto each other. That means this is by SSS postulate, essentially. All right. How about the next one? Use a compass and straight edge. Construct a inscribed square on circle T below. So now, how are we gonna construct a circle? I mean the square. I'm just gonna use. There's different ways of doing it. I'm just gonna first use the line that passes through the center, which is the diameter, and then using a compass, I'm going to get the perpendicular bisector of that, more than halfway, perpendicular bisector of the all right, diameter, and then draw the other line. Now then we have divided the circle into four equal pieces. All I have to do now is simply connect those 4 corners. And then connect here, connect here. Then you can see the black one must be a square inside. All right, let's move on to the next one. Number 26. Diagram below shows the parallelogram and then angles that are given in this way. Explain why angle NLO is 40 degrees. Then first we have to realize a couple of things here. Since this is 22 degrees, this will be 22 degrees. Why? By alternate interior angles. So we have to realize that. Then measure of angle NLM is 22 degrees because angle NLM is congruent to angle LNO by alternate interior angles. Now, then if I were to call this angle as X, let us say I didn't know, I want to show that it's 40. So when I add up all these angles here, they have to be added up to 180 because consecutive angles add up to 180. So we get X plus 22 plus 118 has to be equal to 180. Why? Consecutive angles in a parallelogram add up to 180. So then in this case we get X plus 140 is equal to 180. Hence X must be equal to 40 degrees. And then you can write it up here. Why? Consecutive angles in parallelogram add up to 180. That's the idea behind it. All right. Now let's look at next question number 27. So here we have A is -6, -5. -6. So 1, 2, 3, 4, 5, 6. -5. 1, 2, 3, 4, 5. So that's a -6, -5. And then the other point is 4, 0. 1, 2, 3, 4. That's a 4, 0. Now we have a directed line segment here between those two points. Now what we want to do is that we want to separate them by 2 to 3 ratio. 2 to 3, that means total is 5. So I can realize that here. If I have to draw the horizontal line segment and the vertical one, I realize that the horizontal difference from -6 to 4 is 10. And that should be equal to 5. Let me just call that as A, 5 portions, because I have to cut them into 2 to 3 ratio. Then A is equal to 2, so that means from here, I need to go for 2 portions of 2, which is 1 portion, 2 portion, right over here. If I have to go up, then that would be my point. I'll be done. But if you want to check from the other side, I can do that as well. Here, the difference has to be 5b. Let me call that as 5b. But total distance is 1, 2, 3, 4, 5. That only makes sense because from 0 through -5. Then b will be equal to 1. From the other point, I have to go down 3 units because 2 to 3 ratio. And then if I have to go, it'll be same location right over here, which is -2, -3 would have been the answer. All right, now let's look at the next question, number 28. In the diagram below shows the ramp, and then 4.5 feet over here, and the ramp measures this much. Determine and state the nearest angle, the angle of elevation formed by the ramp and then the ground. So I'm looking for this as x. Then I realize that they're in the sine relationship, sine ratio. So we get sine of x must be opposite, which is 4.5, over hypotenuse, which is 11.75. To find the x, I just have to use the second sine, or arc sine. So put that into calculator. Second sine 4.5 divided by 11.75. Then I realize it's a 22.5. They want it to be nearest degree, so I'm going to write down 23 degrees. All right, let's move on to the next question, number 29. Area of the shaded sector is 12 pi. This is 12 pi. And the length of OA is 6 inches. Determine the measure of the angle AOC. The area of the sector is in fact found by the angle over 360 degrees, and then pi r square, meaning the proportional to the that ratio of the entire area of a circle. So we get 12 pi must be equal to angle over 360 degrees, and pi and r is equal to 6 here, so 6 square. Then pi cancels out, and then 6 square is equal to 36, so 36 cancels out with the 360, leaves me 10. Then my equation is 12 equals theta over 10, put it over 1, and theta is equal to 120 degrees. That becomes our answer. Number 30. After a reflection over a line triangle A prime, B prime, C prime is the image of this one. Explain why triangle ABC is congruent to triangle A prime, B prime, C prime. Simply put, a reflection is a rigid motion that preserves distance and angles. Therefore, image after a reflection is congruent to the original image. That's it. So something like that would have been good enough. All right, let's look at number 31. A flagpole casts shadow of this much. So I have, imagine if I have the land, there's a flagpole right over here, and then shadows, cast a shadow of 16.6 meters long, while Tim stands distance of 12.45 meters from the base of the flagpole. So Tim is right over here. That's the 12.45, while this one is 16.60. Such that the end of the tip's shadow meets the end of flagpole's shadow. So in fact, what I have to do is maybe I should bring this one over to the other side. And I'll just make it a bit bigger. Oops, not that one, but this one. Maybe I'll just draw a longer one on the same side, just to see a bit better. And then his shadow will be same location. Now, if Tim is 1.65 meters tall, so here we get Tim is 1.65 meters tall. Determine and state the height of the flagpole. So that means difference in 16.6 over here and 12.45 would have been the length of the Tim's shadow. So let's look at it then. Here I'm going to have 16.6 minus 12.45. Then we get 4.15. So then here we get, this is 4.15. The ratio is that this cast this much, so then I get 1.65 cast 4.15. That will be the same ratio as the flagpole. I'm going to call that as x, which cast 16.6. So I can figure out the value of x. So I get 4.15x must be equal to 1.65 times 16.6, 27.39. So I'm going to divide that by 4.15. Then I get 6.6. That becomes our answer. All right, let's move on to the next question. Number 32. In the diagram below, and GH as such, then GH is congruent to IH. So GH, which is this line segment, is congruent to IH. That means this angle is congruent to this angle due to isosceles triangle. Now, and then we realize that angle EGB, this angle is 50. And then DIG, this one is 115. Explain why those two lines are parallel. In order for us to show that the two lines are parallel, either alternate interior angles are congruent or corresponding angles are congruent as well. We have to figure something like that. Now, then we get to see that this is 115. That means this one is, by supplementary angles, we get to realize that this is 65. But since this is 65, this one must be 65 as well. Then you can figure out this angle to be 180 out of the triangle, subtract 130, which is combination of these two, then it gets us 50. Then notice that these are corresponding angles. When corresponding angles are congruent, then we realize that those two lines are being cut by the transversal must be parallel. So that's basically what we can write. All right, number 33. So let's look at this one. Quadrilateral ABCD is a parallelogram with diagonals AC and then BD. We need to show that the triangle AED, this triangle is congruent to CEB. We have to show that those two triangles are congruent. How is it possible? So now, what we can do is we can say that diagonals by, if you want me to write it up, I guess I can kind of do that a little bit here. So I'm gonna, this is a statement. And this is the reason. Now, so first one, based, let us say I wrote down all the givens. Now we get to realize that second one, I can say that AE is equal to CE, so as DE is equal to DE. Why are they equal to each other? Diagonals bisect each other in a parallelogram. All right. So that's why we can show that this is equal to this one and this one is equal to this one. And number 3, we can say that AD, we can say they're congruent. And AD is congruent to BC. Why? Opposite sides are equal to each other. So congruent in a parallelogram. Now, then we just show that number 4, triangle AED is congruent to triangle CEB by SSS. Now, then describe a single rigid motion. How can you map this one onto this one or either way? Only thing which we have to do is somehow, E doesn't matter, E is shared by both. C has to correspond to A. That means this one has to go all the way over here. And then B has to correspond to D. In fact, what I'm doing is I'm rotating each one of them by 180 degrees. Centered at E. Since starting from here, triangle CEB, let me just follow their lettering here. CEB is rotated 180 degrees about point E, gets me triangle AED. That's why by rotation we get to see that these two are congruent to each other, where rotation is one of the rigid motions. All right, let's look at number 34. So in this question, we are looking at the line of sight from the park rangers station P, park ranger is right over here, to the lifeguard chair L on the beach on a lake perpendicular to the path joining campground C over here, and then first aid station right over here. And we get to realize that the lifeguard, so here the straight path from the both campground and the first aid station are perpendicular. So they're all talking about perpendicular here. We realize that this is 0.55, as you can see here, and this is 0.25. They're given to us. Determine the state to the nearest hundredth of a mile. The distance between park ranger, which is right over here, park ranger station, and then the lifeguard chair. Let me call that as x. We need to figure that out first. In fact, that's relatively not bad because we can just use the Pythagorean theorem. Now, Gerald believes that the distance from the first aid station to the campground, which is this one, is at least 1.5 miles. Is Gerald correct? So we have two questions going on. To find x, we will be using Pythagorean theorem equals 0.55 square. Then you can see that .55 square minus 0.25 square, by moving this one over to the other side, should be equal to that value. But what we want to do is we want to take the square root of it. Square root of that value. Then we get x equals 0.49 to the nearest hundredth. Now, so that's the answer. How about FC. We can use the similar triangle concept where this square, 0.55 square, is equal to this portion, which is 0.25 times FC. Then FC, which is the distance between those two, would have been equal to this one square divided by that one. So we get 0.55 square divided by 0.25. And it's going to be 1.21. So now, in fact, the distance is 1.21. Is that at least 1.5 miles? No, not really. Since 1.21 is less than 1.5, Gerald is not correct. Alrighty. Let's look at number 35. The water tower in the picture below is modeled by two-dimensional figure that we see over here. Now, if AC is 8.5 and BF is 25, and then the angle here is equal to 47 degrees, and determine and state to the nearest cubic foot of the volume of the water tower. Volume, that means here we have a hemisphere, so let me call that as a 1, 2, and then 3. So how do you find the first one? This is a 8.5 radius, then this is a 8.5 radius, so as this one to be 8.5 radius, either this way or this way. To find 1, we have to get 1/3 because it's a cone. Pi r is equal to 8.5 times the height. In order for you to figure out the height, I can use the tangent of 47. So we get tangent of 47 degrees must be equal to h, which is this one, height, over 8.5. So h will be equal to, I'm going to use the calculator here, tangent of 47 multiply that by 8.5, 9.115. So that's what we end up getting here. So 9.115. So then I'm going to multiply that by 9.115 is multiplied to this entire expression. Then I'll be getting 1 divided by 3. Multiply that by pi. Multiply that by 8.5 square. And multiply that by the answer that's given. Then we get 6. So that becomes 689. So 689.65. I'm going to round it to the nearest cubic foot at the end. Second one, how do you do it? Second one is the cylinder that we'll be end up getting. So we get pi r, which is 8.5 square times 25. It's pi r square h. So we get pi times 8.5 square times 25. So that's what we end up getting. So our answer here is 5674.50. Now let me go for the third one. Third one is the, in fact, hemisphere. So instead of 4/3 pi r cubed, we're going to have 2/3 pi r equals 8.5 square. So we're going to have 2/3 times is pi, actually pi r cube here, I don't know why I put square, pi r, which is 8.5 cube raised by third power. Then we get 1, 2, 1, 2, 8, 6.22. So when I add up all three of them, that would have been a total volume I'm going to add the previous answer plus that answer plus that answer. Then we get 7650. Seven six 50.37, but round to the nearest cubic foot. That's basically what we will end up getting. Now, second, so we found the volume, but a water tower was constructed to hold maximum of 400,000 pounds, and then they are looking for 62.4 pounds per cubic foot. Can the water tower be filled to 85% of its volume and not exceeding the weight limit? So we're not getting everything, but 85% of that. So then, second part of the question is that part 2 is 85% of the volume. So 7650. But we have to multiply that by the density, which is 62.4. What will this be equal to? So 0.85 times 7650 times 62.4. So 4405756. And since this one is greater, so the answer is no, because this one is greater than maximum weight, which is 400,000 pounds. So therefore, it's not possible. All right, so let's look at the next question. Number 36. We have a triangle here. Prove that the triangle is a right triangle. How do you prove that something is a right triangle? We have to show that it has a right angle. Let's try to plot the points first. 6 and negative 1. So 1, 2, 3, 4, 5, 6 and negative 1. That's R. And then S is the 1 and negative 4. 1, 2, 3, 4. That's S. And then negative 5 and 6. Negative 5, which is 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6. So that's the T. Now, how can we show that it's a right triangle? We just have to show that. Let me try to connect those points first. It looks like this seems to be the right angle. Then what I like to do is I like to calculate the slope of the RS and then calculate the slope of TS, and then hopefully they will be negative reciprocal to it. What is the slope of RS? RS here is, I'm going to, the change of y, so which is negative 4 minus negative 1 divided by 1 minus 6, which becomes here negative 3, because negative 4 plus 1, and over negative 5, which is 3 over 5. That's what we end up getting. How about the slope of TS? So we can do 6 minus negative 4 over negative 5 minus 1. Then we get 10 over negative 6, which is negative 5 over 3. So we can say that since the slope of RS times slope of TS is equal to negative 1. The fact that they're negative reciprocal to each other, that means when you multiply those two slopes will be equal to negative 1. We know that TS is perpendicular to RS, which leads to angle S is a right angle. 3 points, meaning therefore triangle RST is a right triangle. Alright, so we proved the first portion. How about the second one? State the coordinate of point P such that it's a rectangle. RSTP. So RSTP to P has to be around here. How can I show that it's a rectangle? So then, rectangle is essentially parallelogram with more restrictions to it. So then, whatever happened from R and S has to happen T and P as well. So from S to R, I moved to the 1, 2, 3, 4, 5, and went up by 3. So I'm going to go 1, 2, 3, 4, 5, and up by 3. So that must be point P. So then, when I connect that one, oops. Now, so green one with the red one should be now becomes a rectangle. How am I going to show that? Since I already proved that this one is a right angle over here, only thing that I have to do is this one is in fact parallelogram. So already I found the two slopes here and here, so I'm just going to find the slope for the other two. TP and then RP. Slope of TP, where P seems to be 0, 9, I guess. 3, 3, 3, yeah, 0, 9. So 9 minus 6. And then 0 minus negative 5, which becomes 3 over 5. Wait a minute. TP, now we know that is parallel to RS. And then let's try to go for RP, slope of RP. Slope of RP is, R is this one, so negative 1. So 9 minus negative 1. And then 0 minus 6. So we get 10 over negative 6, which is equal to negative 5 over 3. And then so here it goes. Since the slope of TP is equal to slope of RS, and then slope of RP is equal to slope of TS, this shows that opposite sides are parallel. Therefore, RSTP is a parallelogram. But since angle, what was the angle here? S was right angle. S is right angle. Therefore, one more time, RSTP is a rectangle because parallelogram with the right angle is a rectangle. And that's it. Have a great day. Bye-bye.